Good morning. So last class I have already shared the notes of Compass survey, isn't it? So I think all of you have got the notes. So what are the principles of Compass survey? There are two principles of Compass survey. Already you know what are they? That means traversing, isn't it? So one is of close traverse, another is often traverse, isn't it? So this is the open traverse, this is the closed traverse. So, and I have already shared the parts of a prismatic compass. These are the different parts, and these are the working principle. Three steps involve centering, leveling, and observing the bearing. Okay, and before that, we have to know what is meridian, uh, true meridian, magnetic meridian, and arbitrary meridian. So, what is a meridian? Meridian is a standard direction from which the bearings of the survey lines are measured. Okay, so this is the survey line, and from which the bearings are measured. That means the angles are taken. That is your meridian. And there are three types of meridian: true meridian, magnetic meridian, and arbitrary meridian. Okay. So what is true meridian? It is a line of intersection of Earth's surface formed by plane passing through north and south poles and in the given place. So magnetic meridian, it is the direction indicated by freely suspended magnetic needle. And it is what is arbitrary meridian? It is a convenient direction assumed as meridian for measuring bearings of survey lines. And what is a bearing? It is a horizontal angle made by survey line with the reference to the meridian based on a meridian of the bearings, a true bearing, magnetic bearing, and arbitrary bearing. What is true bearing? The angle made by a survey line with reference to true meridian is called a true bearing. It is always remains constant. Next is magnetic bearing. The angle made by a survey line with reference to magnetic meridian is called magnetic bearing. It changes from place to place and time to time. Time to time. Arbitrary bearing, the angle made by survey line with reference to arbitrary meridian is called a arbitrary bearing. So already I have told you what is whole circle bearing system or quadrilateral bearing system. In whole circle, it is measured from the angles are from 0 to 360 degree, and in quadrilateral, it is represented by different quadrant. Okay, so this is north, northeast, northwest, north south, like that. Conversion of whole circle bearing into quadrilateral bearing. The whole circle bearing of a line can be converted. From whole circle, we can convert into quadrantal bearing system. So, for example, convert the following whole circle bearing of lines to quadrilateral bearings. OA 32 degree. So, OA 32 degree means this is your O. OA is showing, suppose this is your OA is 32 degree. This line represents 32 degree. In whole circle bearing, it is 32 degree. So you have to convert it into quadrilateral bearings. So in which quadrant it is? So whole circle bearing of OA is 32 degree. So quadrilateral bearing will be, see in the figure, it is in north. So direction here, it is north, it is east, it is north, it is east, and it is north south. Here it is west. Okay. So OA 32 means quadrant bearing, it will be north 32 degree east. Okay. The direction you have to show. And OA 109. 109 is somewhat this line, isn't it? More than 90 degree. So what is the quadrant bearing? Southeast. This quadrant. So if quadrantal bearing will be, okay. So quadrantal bearing, how can I convert? 108 minus WCB. 109. Oh, sorry. It should be 180 degree. Okay. Quadrantal bearing will be 180 minus whole circle bearing. So in quadrantal bearing, what is the angle? You have to minus 180 degree minus this angle. So 180 degree minus 109 degree, it will be as 71 degree east. This way you have to convert. Have you understood? It is not 108, okay? It is 180 minus WCB.
Hello, ma'am.
Next, yes,
Ma'am, which line is 0 degree?
this one, this line, this is your 0 degree, okay? From 0 degree is here. What, and this angle is 360 degree in whole circle bearing, okay? 0 to 360. This is not 0, this is O, okay? This is O. And third one, number C point is OC 211. 211 is somewhat this angle, isn't it? This angle? Oh, sorry, somewhat this angle. Okay. 180 and plus 211 means what? 180 degree something plus something. So in this line, how can you convert? We have to convert like quadrilateral bearing WCB, whole circle bearing minus 180 degree. And one the angle is 211 minus 180. We have, and what is the quadrant? The quadrant will be as 31 degree. It is 31 degree, I think. 118 minus 211. Oh, sorry, 211 minus 1. That's not sure. 11 minus 1, 2. 31 degree. Yes, it is 31 degree. The direction is southwest. In this quadrant it is. Okay. So the third problem, how can I convert? The third angle is it is this angle. And this angle automatically lies in this quadrant. That means south and south and west. And how can you calculate this angle? You have to convert whole circle bearing minus 180 degree and it will give this angle, isn't it? So 31 degree south, direction is south and east. And last one, WCP of OD, that is 303 degree. 303 degree. 303 degree means what is the angle? This one, 303, isn't it? This one is 180. 180 plus 90 is how much? 270. So 270 plus something. So this angle and the quadrant is DA, isn't it? Not DA, the direction. North. This is north. This is your east. Whenever you do such type of problem, you just draw the direction diagram and then you have to convert. Okay. North, this is your west, and this is your south. So automatically it is lies in west and northwest direction. So how can you calculate this angle? It will be this angle minus no 360 degree minus whole circle bearing. So 360 degree. The angle given is 303. So it is north 57 degree west. Okay. These way we have to convert from whole circle bearing to quadrantal bearing. Whole circle means always remember whole circle means it is 360 degree. The angle is from 0 to 360 degree. Okay. Next, next we have convert the following reduced bearing. So here we have what reduced bearing means. What? Can you tell me? What do you mean by reduced bearing? Last class I have discussed. Reduced bearing means quadrantal bearing. Okay? Where angle lies from this quadrant, this quadrant, this quadrant. Okay? That is your reduced bearing. So you have to convert reduced bearing angles to whole circle bearings. How? First is north 52 degree 30 minute. So 52 degree. Do you know how to write minute? 52 degree is given, and suppose 30 minutes, there it is given like this. This, okay? 52 degree and half of 1 degree. That is your 30 minute, okay? So reduced bearing is given north, this direction, which is in the northeast quadrant. So therefore, the whole circle bearing will be, what will be the WCB? Can you tell me? Question no? Oh, so what will be the RB? Suppose northeast direction means northeast quadrant means what? This quadrant. So whole circle bearing will be this one only. The same answer will be same. Okay. And next is south 30 degree 15 minute east, which is in southeast. Let me draw southeast. You can start writing your enrollment IDs in chat box. Okay. Now this is your south and 30 degree. This that means this quadrant. So the WCB will be 180 degree. This angle. So WCB will be 180 degree plus, oh, sorry, 180 degree minus this angle. So it will be 149 degree. Okay. Similarly, if it is in this quadrant, then you have to convert the whole circle you have to find the whole circle bearing like 180 degree plus this angle. Okay. Then you will get in quadrant at this quadrant angle.
Ma'am,
Next,
hello.
yes,
Ma'am, how do you minus minute?
this minute.
Yes, ma'am.
Okay, minute you have to minus, here it is 180 minus 30. So 180, let me show you. 180 degree. There is nothing. That means it has 0, 0 minute. Okay. Then 1, suppose 30 degree, 15 minute. Then you minus how much it will be. 180 degree, nothing means there is 0, 0 minute. Okay. Minus 30.1. 30 degree, 15 minute. 15 minutes, 180 degree. Let me take another 180 plus 85.45. And this is 360 degree. 360 minus 15.10. 149. 45 plus 60. Okay, I'll tell you later how this minus how this degree can be uh, minute can be subtracted. Okay. Next is compass traversing in the field. So, what are the instruments required for compass traversing? One is prismatic compass, chain, arrows, tape, ranging rods, and pegs. The compass traversing of an area, first you have to reconnaissance of the area. Next, determining the direction of the lines, then measuring the traverse legs and offsets. And forward and back bearings. I have told you what is forward bearing and what is back bearing. Okay. Next, we have a problem. The difference between the forward bearing and back bearing of a line is 180 degree. Okay. So this is the generally this is one formula. Back bearing equal to forward bearing plus minus 180 degree. Next, the following are the observed for forward bearings of a line. Find the back bearings. So four bearings are given. You have to find the back bearings. AB 42 degree 45 minutes. Again, this angle multiplication minute addition is comes here. 42 degree 45 minutes. Back bearing will be plus 180 degree. So it will be 40 or 222 degree 45 minutes. And next one is local attraction. What is local attraction? So a prismatic compass generally works under a magnetic needle. So if it has a magnet, it will attract some substances, iron substances, isn't it? So that will be a local attraction. And due to these substances present in the field, surrounding field, the needles may deflect it and it will show some deflection due to this iron or steel substances. Okay, so that is your local attraction. A compass needle is affected by the presence of masses of iron and steel, such as lamp posts. Suppose there may be a lamp post of electric cables, steel girders. There may be some steel girders. Okay, so they deflect the needle, and the effect of this disturbance is called local attraction. Okay, due to the presence of this iron and steel, the needles gets deflected, and that is a local attraction. Due to local attraction, the difference between the forward bearing and back bearing of a survey line will not be equal to 180 degree. So due to local attraction, we will not get the forward bearing and back bearing. Total angle measured is 180 degree. Okay. The observed bearing of lines affected by local attraction and are corrected by starting from the unaffected line, and the correct bearings of the successive lines are correct bearings of the successive lines are calculated. So in this problem, line AB, line BC, line CD, and DA is considered, and their forward bearings and back bearings are given. So you have to correct the bearings from local attraction. Again, addition is multiplication is comes here. Addition subtraction is come. Observe forward bearing of BC. It is observed that the difference between the forward bearing and back bearing of the line is line AB is exactly 180 degree. Hence, station A and B are free from local attraction. And the bearing observed A and B are correct. If the forward bearing and back bearing differences is 180 degree, that means there is no local attraction. Okay. And if you have got, well, suppose in line BC, suppose if you minus, if you have got, so the difference is a little bit different from 180 degree, then there may be some local attraction. The difference of forward bearing and back bearing of the lines is is not 180 degree. Local attraction is present at those stations. The observed forward bearing of BC, this line, is also correct since B is unaffected by local attraction. Can you see the difference between this line, forward bearing and back bearing? Let me check. 294.15 minus 115.15. Forward bearing of line BC is 100 this one, and if you add 180 degree, then correct line of BC will be 295 degree. So there is a 1 degree missing. So the errors due to local attraction will be 180 degree. If you add these two lines, that means if you the difference between these two forward bearing and back bearing is not 180 degree. It is 179 degree. Okay. So there will be error of 1 degree due to local attraction. Next, CD line. Since the error is negative, all the bearings observed C must be corrected by adding 1 degree. Least count of a prismatic compass is 1 degree. Okay. Least count of a prismatic compass is 1 degree. Okay, can I add degree here? The least count of a prismatic compass is 1 degree. That is your 30 minute. I forgot. That is not 1 degree. Okay. So in last, let's see what are the errors. Errors in compass survey. Uh, Natural errors, errors of manipulation and sighting, errors due to external influences. What may be the natural errors? These errors may be due to sighting, due to external influences. That means local attraction. Okay. Errors of manipulation, sighting, inaccurate centering of the compass, inaccurate leveling of the compass box, imperfect bisection of ranging rods at stations, carelessness of in reading and graduations, carelessness in recording the observed readings, magnetic changes in atmosphere, errors detection influences, magnetic changes in atmosphere on a cloudy or stormy day, variation in declinations, and local attraction due to proximity of steel structure. Instrumental errors, the needle may not be perfectly straight, the pivot may be bent. That means if this where the needle is attached, it may be bent. That means it may not be perfectly straight. The needle bent, needle being sluggish, the needle not moving freely. The line of sight is not being vertical, the gradation circle is not being horizontal, the line of sight is not passing through the center of graduated ring, and the vertical hair being loose. The vertical hair in the eyepiece, it may be loose. Okay, so I'll discuss about this problem in the next class. Okay, how the local attractions is calculated. All of you write down your at enrollment IDs in chat box. Anyone left? I'm taking screenshot. Okay, anyone left? Okay, anyone left? You can leave now.